When it comes to winning races, the pros know what it takes. They know that winning is the end result of painstaking detail, teamwork, and carefully chosen performance parts that deliver the goods. Parts like those from Direct Connection.
Today we're here to talk in this Direct Connection video how to phase a camshaft in the V8 engine. We've taken a little twist today. We've asked John Crawford to be here to ask the questions that you, the viewer, might have about the things that we're going to do, questions that he can ask for you.
Well, let me ask you the first and probably the most obvious question. What difference does phasing the camshaft really make?
Well, phasing the camshaft or centerlining the camshaft is merely talking about the alignment of the camshaft to the crankshaft. The way you're taught in the service manual is to line up the dots. That's fine for a passenger car. In a race engine, this alignment is very critical. So we use tools like a dial indicator and a degree wheel, offset keys, to facilitate this. We can move this in relation to this in incremental amounts of 1 degree.
Well, what difference does it make if you don't do it properly?
If you don't do it properly, you lose some of what you just paid for on a camshaft.
So now it's a horsepower consideration.
Absolutely. We've tested all sorts of positions of the camshaft to the crankshaft on the dynamometer in the race car. Direct Connection has come up with a recommended setting or center line for each camshaft. That's included in the instructions.
So what happens is you buy the camshaft, but you don't have to pay for the engineering. It's already been done.
That's right. Today we're going to deal with the Chrysler V8s. This, of course, is the Hemi, the 360, and the 440.
Since we've got all the gear on the 360 and we're going to talk about the camshaft, why don't you get this Hemi out of the way? I'll pull the 360 out and we can get started.
Sounds good to me. Okay, we're going to start by taking the water pump off, which I've loosened up already. The next thing we have to take off is the damper. John, you can give me a hand here.
Okay.
Why don't you hold the crankshaft? We put a couple of bolts in the crank so he can hold it. I'll get this long breaker bar here. Loosen that up. What we're going to have to do now is use a damper puller.
Now it's pretty obvious the sequence that we'd use on this, isn't it, Bill? I mean, it's just like you do for any camshaft installation right out of the service manual, right?
Right.
Okay.
This is all pretty straightforward. It's all covered in the Mopar service manual. And get this on there. It's important to have equal pressure on the damper. That allows you to pull it evenly. Never beat with a hammer on the outer ring because that's connected with rubber to the inner ring.
Okay, so we want to make sure that if we're doing this, that we have the proper damper puller. And you can get that at any auto parts or supply store, I assume.
Right. Now, if you'll continue to hold there, John, this should come right off. We'll take the front cover off. First, we'll pull the fuel hose off here. Then we'll pull this off. I'm pulling the front cover and the fuel pump as one unit. I've loosened the oil pan up. Got to take these bolts out. This is something like you might want to do in the car if you were at the drag strip or the racetrack and had to change a cam. On the A engine, which is 360, 318, or 340, you can manage this by loosening the oil pan. You don't have to take the oil pan all the way off.
The 273 is also in the A engine family, isn't it?
Right.
So this would be a time-saving measure if you were at the drag strip between runs or trying to work in the pits at a race.
Right. You will have to take the fuel pump back off to reinstall it, since the fuel pump push rod has to ride on the eccentric, or fuel pump arm. Now we get to the meat of the problem. This is the fuel pump eccentric, which will come off. We'll begin by taking that off. This allows us to get right to the cam gear and timing chain. Now you'll notice on the A engine, unlike the Hemi, there's a key here. In order to centerline or phase the camshaft, this key is what's known as an offset key. It is offset either way to provide the degree setting that you will need. You have to pull these off sequentially. Sometimes they're a little tricky, and it comes right off. The way we normally get this key out is by placing the screwdriver here and pushing. Now you'll notice this is what's known as a straight key. There's no offset. We'll use an offset key, one which has some offset in it, if we want to move the camshaft in relation to the crankshaft incrementally, a degree or two.
So 1 or 2 degrees really does make a difference then?
Absolutely. 1 or 2 degrees you can see on the dynamometer in the car. 4 degrees is a world of difference. Okay, the first thing we're going to do is reinstall the chain and see where we are. We're using a straight key, one with no offset. Put the key in the key slot. Put this back on. Now we did not move the crank or the camshaft.
Okay, so in this case we don't have to worry about alignment, but the service manual covers what would happen if we think the crankshaft or camshaft's moved.
That's correct. Now, what you're going to have to do, John, is pull the #1 spark plug out and install the top dead center tool.
Okay, that's a direct connection part, if I remember correctly?
Right. This part will stop the piston before top dead center. And I'll show you how that works in a second.
Okay, we just installed this finger tight, correct?
Right. I've already preset that so that it's correct. The instructions on how to preset it for your engine are given with the part.
Okay, the TDC tool's in. What's next?
Okay, we're going to mount the degree wheel. Now this degree wheel we'll be using today, direct connection piece, it's available 0 to 180 degrees.
Some of the degree wheels I've seen in the past, Bill, are 0, 90, 0 wheels. What's the advantage of the DC wheel that's 0 to 180?
Well, this one from DC is 0 to 180. The ones you may have seen go 0 to 90 to 0. When we centerline a camshaft, we work roughly from 65 degrees to 130, 150, around in there. What happens is that after you get past 90 on the other wheel, it starts going back down. So you have to remember to add the increments to get up to 140 degrees or whatever you're using. This one has it clearly printed, less chance of a mistake.
Okay. So basically then that just makes it simpler.
That's correct. I'm going to start by putting this degree wheel on the crank. John, why don't you make us one of those real expensive things called a pointer. Take that piece of coat hanger over there and bend it up so that we can go from this bolt hole on the front of the block down to the degree wheel. So we need that pointer just as a point of reference. There we go. And I take this bolt that I rubbed out of the timing cover, screw it into this bolt hole here, it'll probably work.
Okay, now this is what we're going to use to begin to make our reference points.
Right. First thing we've got to do is find out where top dead center is. That's why I had you put the top dead center stop in there.
Okay.
And we need something to keep track of where the degree wheel is, and that's what this pointer does. Okay, now we got that done. Next thing we've got to do is find top dead center. When you put the stop in there, It's adjusted so that the piston will come up and stop just before top dead center. So I'm going to take this long breaker bar here so I got good control. I took the spark plugs out so it rotates freely. I'm going to start down here and very gently crank this around in a clockwise direction.
If I understand correctly now, when we begin to come up on top dead center, if we encounter any resistance at all, we want to stop to make sure that we don't break the top dead center tool or put a hole in the piston.
Right. Now you'll hear it coming up on compression. Actually, it's forcing the air past that stop. There it's stopped.
Okay.
Don't force it at this point or you'll poke a hole in the top of your piston. Now, let's bring this down. Let's just try and start at 20. So we'll put it there at 20. Now,
okay, now I would think that since we've talked about 1 or 2 degrees being critical, that we've got to make very sure that the pointer is solid and is not going to be moving around while we're doing the work with the degree wheel.
you're right. Right now we're going to adjust the pointer, and once we adjust it so that we're sure we have top dead center, then we'll be very careful never to touch it again until we're finished.
Okay.
Now, we're going to rotate this in a counterclockwise direction.
Okay, we went clockwise last
We
time.
went clockwise, we couldn't go all the way around because we hit the stop.
Okay.
Now we're going to back it up, counterclockwise. We're going to wait for it as it approaches top dead center again. We're going to feel for it to hit that stop.
All right, once again with the same consideration that once we hit the stop, we want to make sure that we don't force it.
Right. We're on the stop now. You notice it's at 15.
Right?
Okay, if we take that 20 and add 15, that's 35.
Right?
If you divide that by 2 to get the average, that's 17 and a half.
Okay.
Divide 35 by 2, you get 17 and a half. Let's move this pointer to 17 and a half. Now, if we go around in a clockwise direction, again, it should stop over here at 17 and a half.
All right, Bill, we've gone clockwise and then counterclockwise, getting a reading both sides. We add those two numbers, divide by 2, which gives us our location, hopefully. We then reset our pointer to that degree level, go clockwise one more time, and we should come up to that same reading.
That's correct.
Okay, with my arm over here, I can feel the compression, so.
Yep, you'll feel it. And look at that.
Right on the money, 17
Right on
and
the
a
money.
half.
Okay, I'm going to back this off slightly to relieve the pressure on that top dead center stop. Why don't you take that out, John?
Okay, what are we going to do now?
I'm going to bring it right up and stop it at 0, which will be top dead center.
Well, why do we know for sure that 0 is going to be top dead center? We've been talking about 17 and a half and 17 and a half and 20 and 15.
Okay, what we did was we, using the tool, stopped it at the same place because the tool wouldn't let us go any further. And that was exactly 17 and a half degrees after and 17 and a half degrees before.
Okay.
Therefore, halfway between those two, which we could have gotten to if the tool were not in there, is really top dead center.
Okay.
That's the beauty of the positive center, positive top dead center stop. Now that is truly top dead center.
Okay, now again, we got to remember, if I understand this correctly, that we've got to be very critical on these measurements because we're getting ready to phase the camshaft now.
That's correct.
Okay.
And we're going to phase this camshaft at 110 degrees after top dead center. Now what does that mean? That means that as the crankshaft goes around, the piston will come down 110 degrees, which will be right over here. After top dead center, the piston will be down around in here. We want the intake valve, which is right here, to be fully open.
Okay, so that means the engine will be breathing better at that point. That'll be its optimum point of breathing for
Right.
intake.
And the way we determined that was very simple. we looked up the part number of the cam in the instructions that came with the cam and looked at the recommended setting. Now, where did the recommended setting come from? Lots of dynamometer research and car testing determined that that was where this camshaft liked to perform in this engine.
One of the things that we do enjoy, and having been using direct connection parts for years, is it seems that when you buy the part, all the engineering's done and you know the pieces work if you follow the direction. It's kind of like you buy the part and you get the engineering for free.
That's exactly right.
Okay, where do we go from here?
Okay, the first thing we have to do is use this dial indicator, which has 1 inch of travel, and put this on the intake valve retainer. Now you'll notice I clamped this on the exhaust port. It's a magnetic base indicator. I'll bring this dial indicator up, and I'm going to position this, lock it down, so that the stem of the indicator is parallel with the valve stem. Now we're going to rotate the engine. From this point on, John, we will always rotate in a clockwise direction.
Okay, because that's the direction that the engine normally runs.
That's correct. And we have the stop out now so that we can go all the way around in a full revolution.
Okay.
The first thing we've got to do is find out where maximum lift occurs. As we approach the lift, you'll see the rocker arm start to move.
Okay.
Now we watch this needle very carefully. When it stops moving, we want to stop rotating the crankshaft.
3, 4, 5 turns.
Okay. Now we set this indicator to 0.
Okay.
Now, what we're going to do is continue rotating the crankshaft in a counterclockwise direction, as I said before. We want to stop it at 50 thousandths before maximum lift.
Okay.
So we've got to go all the way through the rotation now.
Okay.
And you'll see the intake valve start to move.
5 revolutions the other way. So there's 1, 2, 3, 4, and this should be 50 thousandths before. Keep coming. That's 50 before.
Okay. Now, we take a reading down here,
Okay.
74 degrees after top dead center. Write that down.
74 degrees APD. Okay.
Now, we continue to rotate in a clockwise direction.
Okay.
The needle will come up to maximum lift and go back down. We want
Okay.
to stop at the same place.
Okay, there's 0, and we're back to 50.
Okay? Now, we take another reading. It's
Okay.
142. Write that down.
142, that would be before top dead center.
No, that would again be after top dead center.
Okay, but it's after the valve lift.
You add those two together,
216,
divide that by 2.
108.
108. That says that the center line, or the maximum lift of the camshaft, occurs at 108 degrees after top dead center.
If I remember correctly from what you told me earlier, for this camshaft and this engine and this application, we should be at 110 degrees. We're at 108 now. What do we do to get to the optimum of 110?
We use this key, which is offset. The top portion is offset 2 degrees from the bottom portion. What this does is that it allows us to move the cam gear in relation to the camshaft in very small increments. We need to move this 2 degrees in relation to the camshaft. So what we'll do, very carefully now, not hitting our pointer, because we've said we weren't going to hit that, we're going to loosen this. May take jiggling this slightly, but since the chain's hooked up, that won't change anything.
Okay, the relationship will stay the same.
That's correct. Sometimes we may have to put a screwdriver behind here, pry a little bit.
Okay.
Again, being very careful that you don't hit your pointer, because if you do, you'll have to start all over again.
Okay.
See how it's coming off?
Mm-hmm. Yeah, you have to make sure that you pull it off evenly, but you got to be very careful because the measurements are so critical.
That's right. You also have to be careful to pull them off a little bit at a time on the crank gear and the cam gear. Now, we will swing this around just like that.
Okay.
We'll
Making
pull-
sure that we don't take either gear out of the chain.
That's correct.
Okay.
We'll remove the standard key,
Okay.
and we'll put in the offset key.
Okay.
Now, there are two ways to do that. We want to make sure that when we put it in, depending on which way, whether it be this way or this way,
Okay, one's going to take us 2 degrees the correct direction. One's going to take us 2 degrees the wrong direction.
that's right. We're at 108 right now. We
Okay.
want to be at 110. We want to retard the camshaft 2 degrees.
Okay.
The easy way to remember that is that the lower the number, the more advanced the cam is. 108 is more advanced than 110.
Okay.
We want to retard the cam. We want to make the number bigger.
All right.
Hold
So,
this up in front of the camshaft without the gear and look at the offset.
okay.
Figure out which way that's going to position the gear. This way, it's going to advance the gear,
Okay, moving the gear clockwise.
which is the same thing as retarding the camshaft.
Okay.
So that's
So
the way we want to
that
put
we
it
want
in.
to put it in.
Put it in here. We rotate this around. Should come back very close. However, it won't be perfect since it's
Because we've
now
gone
2
2
degrees.
Okay.
All right. Try not to drop the key.
Okay.
Being careful not to hit the pointer. And remembering to slide the gears on at the same time, parallel.
Okay, now if I remember correctly, it's not going to line up exactly right because we changed it 2 degrees.
That's correct. You're going to have to rotate it slightly to get it to go all the way on. Okay, now, there we go. Now it's on. Now we're ready to check it. You might want to put the bolt in here just to make sure the camshaft gear does not come off. Let's put that in finger tight. Now, John, if you'll watch the indicator,
Okay.
we're going to run it clockwise around until it reaches 50 thousandths before max lift. It should be coming up right there.
Okay.
Okay, we're at 76 degrees. Write that down.
Okay.
And we go up to max lift,
And then 50 before.
50 after.
After. Okay. So we're doing just the same thing that we did to check it when we found we were at 108.
That's correct.
Okay, and that should be it right there.
It's 144. Okay, you'll add those two together.
That's 220.
Divide that by 2.
That's 110.
It's 110.
And that's where we need to be.
That's exactly where we need to be. Now, before we forget, let's take this bolt out. Remember to put the eccentric on.
Okay, this is our fuel pump eccentric.
That's correct. Locate it over the key. Sometimes it helps to put a out of Loctite on that bolt too.
Okay.
From there, you torque up the bolt. Now, at this point, what we like to do is after we've torqued the bolt up, we double check it one more time.
Okay, using exactly the same procedure, 50 before and then 50 after. Add the two numbers off your degree wheel, divide by 2, and we should get 110 again.
That's correct. And then there's one other double check. And that is to take your stop, put it back in, and bring your engine up. And it should stop at 17.5 degrees before top center.
Okay.
That makes sure that you haven't accidentally hit the pointer. If it doesn't stop at 17.5 before top dead center, then you've got to start all over.
You know, Bill, this may be a little strange now that we've got everything done, but we've taken all of our measurements off of the valve retainer. And that would indicate that we've got mechanical lifters because we've got a direct ratio. What happens if we're installing this camshaft in an engine with hydraulic lifters?
Well, that's a good question, John. A lot of the direct connection cams are hydraulics. Obviously, if a cam is a mechanical cam, which this is, you have to use mechanical lifters. If it's a hydraulic cam, you must use hydraulic lifters. However, if we were going to use a hydraulic cam and phase the camshaft as we did in this demonstration, we would have to remove the manifold, which would be part of the process of installing the cam anyway. We would use a solid lifter, which you could get from a dealer or from a junkyard and clean it up, slip that into the number 1 intake bore for the lifter, and perform the center lining procedure, phasing the camshaft as we just did. When you're all done, remove the solid lifter and replace it with a hydraulic lifter.
So if I understand you correctly, Bill, the procedure for a hydraulic camshaft is exactly the same as for this mechanical, more racing type camshaft. But it still requires that just for the phasing portion of the process, we install one mechanical lifter so that we have this relationship. Then we pull that lifter out, put in our 16 hydraulics, and we've got the camshaft phased for a hydraulic camshaft just like we would for a mechanical camshaft.
That's correct, John. The thing to remember after all of this, though, is that you have changed the timing from the camshaft to the crankshaft by 2 degrees. Don't forget to reset your timing.
2 degrees.
You'll have to reset the timing with a light. It should be 2 degrees. But check it and see.
Okay. Now, if I know how to do this on a 360, does that mean I can do it on any of the line of Chrysler V8s?
Yes. There are a couple of things that you need to know about each of the families, though. Tell you what, let me get the Hemi. If you'll move this 360, we'll bring the Hemi back and show you a couple of important things.
Okay.
Now, the thing to remember about the Hemi is because of its valve train, the dual rocker shaft, the lifter bores are reversed. In the A engine, or 360, which you just did, the intake lifter bore was the second one back. In the Hemi, the intake lifter bore is the first one back, from the front of the engine, the number 1 cylinder.
Okay.
That's easy to get confused on. The other thing that's different is the timing gear. The Hemi, you'll notice, uses 3 bolts. It has a dowel pin as opposed to a keyway in the end of the shaft. And the way we move the cam gear on the cam is by using one of these little eccentrics here. You'll notice they're called eccentrics because they incrementally move the pin in relation to the gear, the same way the little key did.
Okay.
So depending on whether you have an A engine, which uses a key, or a B engine, or Hemi, which uses what we call the offset dowel.
Okay, the B engine would be the 440, for example.
Right. 361, 383, 400, 440.
Okay.
And Hemi, 426 wedge. Now, what you'll have to do is bore out the gear to fit the enlarged diameter of this eccentric. These instructions are included with each package of dowel eccentrics.
Okay.
The other thing to remember is once it's in place and you're happy with it, you should make sure that the eccentric cannot come out.
Okay, do you have anything that you would recommend to use to make sure that the eccentric doesn't come out?
We counterbore the gear from the back side so that the eccentric is trapped between the gear and the camshaft. That way it can't come out. Other people use a plate. It's simple to make a plate if you're at home by simply taking a piece of thin sheet metal, drilling 3 bolt holes in it, and you can put it on between the gear and under the bolts. That prevents the eccentric from coming out.
Okay, on the Hemi and the 440 and so forth, just like on our 360 family engines, the thing that we've got to remember again is we're dealing with a degree or two to get the maximum performance from the car. So I would assume that here, as with the other engines, being very, very careful of our tolerances is critical for our performance.
Absolutely. If you don't follow the camshaft phasing instructions, you're relying on production tolerances. The tolerance of the keyway to the crankshaft, the tolerance of the keyway to the gear, and so on. All those tolerances could stack up in the wrong way. You could be possibly as much as 4 or 5 degrees off. In order to maximize the effect of your camshaft, we recommend absolutely that you phase the camshaft with the instructions given.
Now, my suggestion would be, having had the opportunity to work with you here, would be that when you begin to start this job, you have a factory service manual and the Direct Connection V8 engine manual. Would that be good help?
Probably the best thing would be to have those 2 manuals and this tape.
So the Hemi then is like all the rest of the B engines, is that correct, Bill?
Not exactly, John. The Hemi's in a class by itself in more ways than one. It has the double overhead rockers. The valve lifter layout is also different. So this kind of makes the Hemi unique. Tell you what, if you'll move the 360, I'll move the Hemi and we'll drag the B engine over here.
Okay.
And what you'll notice right away that's different about the B engine is that the heads are obviously smaller. Internally, though, the layout is very much the same. The lifter bores are in the same place as the Hemi, however, the lifters are reversed. The second one back is the intake lifter, just as it was in the A engine. The cam gears are different. Some of them in the B engine are single bolt. Most passenger car applications are single bolt. The Hemi was always a 3 bolt. The key thing to remember is that the bushing that we used in the Hemi, this offset bushing here, is what you're going to need to move the camshaft in the B engine, be it a single bolt as the A engine was or 3 bolt like this Hemi one is.
So we use the Woodruff key in the A engine and the offset eccentric in the B engine, whether it's a 440 or a Hemi or a wedge.
That's correct.
So what we've done now today is we've had the opportunity to go through the whole procedure on the A engine. We've seen the differences on the B engine, the wedge, the 440, and of course the Hemi. And one of the things that at least it showed me was the attention to detail. We've seen that even 2 degrees in cam timing can make a real difference in the performance of the car, and there's no doubt that over the years Chrysler certainly had a good performance record, and it's that attention to detail that's made them successful.
That's true, John, and Direct Connection has carried on that Chrysler tradition of engineering and attention to detail both in their camshaft line and all the rest of their parts, which makes it easy to be a winner.
Well, Bill, I sure do appreciate the opportunity to come in here and learn a bit about this and to see a bit about what it is that actually makes the Direct Connection parts work so well in the Mopar products.
Well, thanks for coming, John. It's been a pleasure.
Take care.
Come back and see us.
Okay.
Whether you're installing a camshaft or building a race car from scratch, you'll want Carroll Shelby's Speed Secrets, a series of performance books from Direct Connection that explain how to go from street to mild competition to full race. The engine manual gives you information about every popular Chrysler performance engine, including the small block and big block Chrysler V8s, the old and new style Hemi engines, Slant 6, Colt and Arrow engines, and Omni and Horizon engines. The chassis manual details front and rear suspension, manual and automatic transmissions, roll cages, drivetrains, fuel delivery systems, hood scoops, race car body modifications, and engine swaps. You'll also find chapters on steering, handling, wheels and tires, aerodynamics, safety equipment, and racing formulas. Carroll Shelby's 2.2 front-wheel drive Speed Secrets covers the new generation of Chrysler front-wheel drive performance cars, including the Dodge Shelby Charger, Plymouth Turismo, Dodge Daytona, and Chrysler Laser in all kinds of motorsports, including road racing, rallying, autocross, and drag racing. Oval Track Modifications is considered the Bible of Mopar oval track racing. It's packed full of technical tips for chassis, drivetrain, suspension, brakes, and body buildup, as well as small block engine preparation. And if you're looking for a handling kit for your Plymouth Turismo, a cam and headers for your Dodge Charger, or maybe a rear window louver for your new Daytona, you'll find all this and much, much more in the Direct Connection Performance Parts Catalog. To order your Direct Connection Performance books, return the order form enclosed with this videotape or write to Direct Connection Catalog Center, 20026 Progress Drive, Strongsville, Ohio, 44136. Yes, at Direct Connection, you'll find the parts, the hands-on information, and the tips from the experts that add up to that extra margin of professional performance.